This is Chapter 1, Section 2, Writing Algebraic Expressions. We're working kind of tangential to yesterday in that we're still working with those algebraic expressions. Yesterday, remember what we did in 1.1 is we actually plugged in a number, substituted a value in for the variable, and we solved them. What we're going to do today is we're going to work forwards and backwards with them. You're going to start off with an algebraic expression, and then you're going to translate it into words. And then you're also going to be able to work the other way, start with a word phrase and translate it back into an algebraic expression. Now, what's important here is that you know your algebraic expression keywords. The algebraic expression keywords are presented to you in the textbook for Chapter 1, Section 2. If you take a look at Chapter 1, Section 2 on page 10 in your math textbook, there is a list of the word phrases and the corresponding operations. So, for instance, as you see on the table on page 10, if you're looking at the textbook right now, you see that the words add and sum and more than, sum, S-U-M, imply addition, and subtract and difference and less than imply subtraction, and multiplied and product and of imply multiplication, and divided and quotient imply division. And again, that list is on page 10 in your math textbook. There's also a reference sheet available to you in the classroom that you can have at your desk with you. You cannot take it home, but you can have it at your desk that has that list of keywords available to you. So, let's take a look here. We've got 9 less than a number W, which is what we're looking at in example 1, part A. Now, let's think about this in a slightly alternate form for a minute so we make sure we translate this correctly. If I said to you 9 less than 10, your automatic thought should be 1, because the number that's 9 less than 10 is 1. What problem did we solve? We solved 10 minus 9. So we're going to be doing the same thing here. Notice here, though, we're using the variable W instead of a number like 10, a variable, which is what makes this an algebraic expression. It has to have that variable. So the number that's 9 less than W has minus 9 at the end, and it's minus subtracting 9, taking 9 away from the variable W, which is why we write W minus 9 for the answer here to 1A. Now, as we take a look at 1B, it's 3 increased by the difference of P and 5. Now, this has multiple components to it. It's not just one symbol with a number or variable on each side. It actually has multiple parts to it. So, if we were talking about solving this question, we'd be talking about using the order of operations. But we're not solving it, we're just translating it. Now, a lot of the times, the big trick to solving these is you're going to be able to translate them in order. You saw that 1A is kind of the exception to that because the minus 9 part came at the end, even though they gave us the 9 up front. But this one really does pretty much translate in order. Now, they've highlighted here on this first line of work just a small part of this expression here where it says the difference of P and 5. And that's what they're going to work through first. All right, the difference of P and 5. Well, difference implies that this is a subtraction problem. And what are we subtracting? Well, if it's a 3 and 5, we'd be subtracting 3 and 5. But it doesn't say 3. It says the variable P. So we're subtracting P and 5, which is exactly what I wrote here. P minus 5. Now, that doesn't take care of the front part of the expression, though, where it says 3 increased by. All right, so I'm going to take that P minus 5, but what am I doing to it? I'm increasing that by 3. And as you can see, that's exactly what we did. We wrote a 3 plus in front, and that is the expression. 3 plus P minus 5. And that would be it. Now, as you can see, one thing I want to note is that P minus 5 is in parentheses. P minus 5 is in parentheses because order of operations wise, if I don't put that P minus 5 in parentheses, that's actually not the order I would do this in. Because addition and subtraction are in the same step, I would do the 3 plus the p and then subtract 5 if it weren't for the parentheses. So those parentheses do group together that difference of p and 5 expression. Okay, let's continue on. All right, in number 2, they're asking us to write a word phrase for the algebraic expression 9 minus 3c. Now, what I want you to know right away here is even though there's one answer given, there's actually lots of different ways to write this. And we can be kind of very simple and straightforward with how we write this, or we can use our mathematical knowledge and terms and make it something that sounds a little more technical in terms of the mathematics. So here, what they did is they went more the simple route here, all right, and they just translated it in order of what they see. So it starts off with 9, so they have 9 here, and then there's a subtraction sign. Now remember, there's lots of ways to imply subtraction, but what they did is they used the word minus. So they've got minus here, and then what are we subtracting now? Well, we're subtracting 3 times c here, which is again what they wrote here. They just wrote it in a slightly different way. Well, what's a way to say multiply? Well, the way to say multiply is product, so they wrote the product. All right, and what are we multiplying together? 3 and c there, and indeed it is 3 times c. So 9 minus the product of 3 and c is how that translates out into words. And that's indeed the answer they've written here, 9 minus the product of 3 and c. Now, contrast with this with 1a. Remember, in 1a, they said something less than, and that was actually the second part of what they're talking about here. So they've just changed the order there in 1a, and you could write it that way as long as you can use the verbiage to make it come out correctly. So you would say, if you wanted to write it like 1a, you would say, in this case, the product of 3c less than 9. Right? That's a little bit awkward mathematically, but it is written more like 1a, where that subtraction is kind of the reverse order there. And again, there's other ways to say this. Here, for instance, some mathematicians will say the quantity 3 times c to indicate that these two are grouped together. That's another way you could go about this. 3 times c subtracted from 9. That would also be a valid answer here. Again, lots of different ways you can write the answer. That is just one of them that you see on the screen. Okay, let's take a look at the next example here. In this next example, it says a restaurant leased its banquet hall for a function. The cost was $10 per person. And we're supposed to write an algebraic expression to evaluate what the cost would be if 20, 21, 22, or 23 people attended the function. Now, we saw back yesterday in 1.1 that we've used this table method to solve problems before. It doesn't necessarily, again, have to be done in a table. It's just a neat way to organize your work. Since the cost was $10 per person, all right, the expression here is 10 times n. And n is simply going to represent the number of people that attended. And you could have picked any variable you wanted. They just happened to pick n to say that. We can think about this in terms of the most simple numbers to see why this works. If just one person went, it would be 10 times 1, or $10. If 2 people went, it would be 10 times 2, or $20. As you can see, as I'm solving here, I'm multiplying by the number of people that went. So when they say times n here, that's going to take care of that for any larger number. Now, they gave us, though, what those larger numbers are, 20, 21, 22, and 23. And I'm plugging each one of those into the expression to solve. So here I've got 10 times 20 for the first one. And again, it's simply these numbers because that's what they told us. 10 times 21 for the second one, 10 times 22 for the third one, and 10 times 23 for the last one. And as you can see, we go through and do those multiplications. I don't really have to think about order of operations here because it's just that one operation. And I see that 20 people is going to cost me $200, 21 is going to cost me $210, 22 is going to cost me $220, and 23 people is going to cost me $230. And that's really all we have to do in example 3. Okay, let's look at number 4 here. It's asking me to write a word problem that can be evaluated by the algebraic expression 27 plus t, and then we're supposed to evaluate the expression for t equals 1.76. So we have to come up with a problem that's going to somehow work with that type of number. So for instance, I probably wouldn't want to talk about the height of a plane, because with those numbers, 27 and 1.76, if we're talking in terms of feet perhaps, a plane flies much higher than 27 feet or 1.76 feet, unless maybe we're talking about the seconds it takes off, just seconds after it takes off. So that probably wouldn't make much sense. So as you can see, what they decided to say here is that Ahmed bought a new sweater for $27 plus the sales tax, which is what they're calling the variable t. If the tax was $1.76, what was the total cost of the sweater? So as you can see, they've got $27 plus the sales tax t takes care of this 27 plus t part. And then they're saying here the tax was $1.76, which takes care of t equaling 1.76. So we've taken care of this first part where they've asked us to write a word problem. Now we have to take care of the second part where they're asking us to evaluate the actual expression. So to evaluate the expression, I'm going to change t into 1.76. So you've got 27 plus the 1.76, which is going to change it to 2876. Or again, in terms of the context of the problem, since we're talking about the cost of the sweater must cost $28.76. Okay, and at this point we're ready to take a look at the check it out problems, the final problems in the section here. So let's go ahead and begin by looking at those. The first one here is asking us to write an algebraic expression for the sum of a number h and 88 minus 4. Now again, we can take a look at this in parts as we did in the one example that we saw earlier. In the very first part here, it's asking us to write something that would express the sum of a number h and 88. Well again, you can reference that table in your book or reference your reference sheet that you have in the classroom. It's saying the sum of a number h and 88. So here what the implication is h plus 88. I know that because the word sum means addition. And I have to add two things together. That's the only way addition could work when there's only two things here, h and 88. So it has to be h plus 88 to start. All right, now, there's a second part to the question, though. It then says minus 4. All right, so now I have to add that onto my expression here in order to say that I'm done. So you have to know what minus means. Well, if you look at your table, minus means subtraction. So now I'm going to include a subtraction sign, and what am I subtracting? Well, there's only one number here. I'm subtracting 4. And as you can see, h plus 88 minus 4 is the final algebraic expression. Now they're asking us to work the other way in example 2. They're asking us to write a word phrase for the algebraic expression 7 plus 19b. Now as you can see, what they've written says 7 plus the product of 19 and b. All right, and that does take care of it. Let's see if there's another way we can write this, though, because that answer really kind of says it all. As you can see in the middle here, all right, this is an addition sign. So we'd be looking for something that implies that I'm going to be adding here. Well, we know that the word sum that we saw just up in that last example does imply addition. So we could start off with the sum. And notice that the pre-written response does not use the word sum, which again goes to my point that there are many different ways to write this. All right, so what are we summing here? All right, we're summing together 7, and I'm starting off with the first part. You could start with the second part, but I'm going to start with this first part here. I'm adding together 7, so we're going to say the sum of 7. And now we'll have to take a look at that last part, 19b. Well, what is 19b? It's 19 times b. So you could say it that way if you wanted to be really blatant. You could say the sum of 7 and 19 times b. But we can say that a little more mathematically sound way. It's a product. Product is one of the ways that implies multiplication. So it's the sum of 7 and the product which again implies multiplication, the product of 19 and b. And again, there's other ways that we'll write that, we can write that, other than the two expressions that are already written on the screen. Okay, let's go ahead and take a look at the final example there, number 3. In question number 3, it says that gasoline costs $2.99 for n gallons. What will be the cost for 10, 12, 14, and 15 gallons? Now remember, when they gave us this type of question a little bit earlier, they actually made a table to solve this question. You don't really have to work that hard, but we can do that if we wanted to. So again, first off, we have to write an algebraic expression. Well, let's think about it in terms of the most simplest problem I could give you. If I just bought 1 gallon of gas, right, that would cost me $2.99 because it's $2.99 per gallon. All right. So if I was solving that, how would I come up with that? Well, if I did $2.99 times 1, that would give me my $2.99 figure. All right. If I did 2 gallons, which simply means I'm going to have to double that out, $2.99, which is going to go to $5.98. What did I do? I did $2.99 times 2. So here, I'm talking about n gallons, which is my variable, which is how I'm going to make this an algebraic expression. We did times 1, we did times 2. Here we're going to do times n. So I'm going to do $2.99 times n for my algebraic expression. So now what I'm going to do is I'm going to plug in each one of those numbers, 10, 12, 14, and 15 for n. So I'm going to do $2.99 times 10, which is $29.90, which is this first answer you see on the screen. And then I'm going to do it for 12. I'm going to do $2.99 times 12. And again, you can do this on the calculator, $35.88. For 14 gallons, I'm going to do $2.99 times 14, which is $41.86. And then finally at 15 gallons, $2.99 times 15, which is $44.85. And that's how we derive the solutions there. And again, you can go and make a quick little table if you wanted to, but it's not absolutely necessary to solve this question or really any other in this one. It's just to help you see where we'll be heading when we actually get into graphing lines with the table method.